We are starting our chapter on quadratic functions. So the first thing that we're going to look at when we're dealing with quadratics is how to solve a quadratic equation by factoring. So linear equations are first degree equations, and you can identify a first degree equation because the variable is only to the first power. When you have a quadratic equation, that means that you're going to have a second degree equation. So the variable is going to be to the second power. So anytime you have a variable to the second power, and that is the degree of your equation, then you know you're dealing with a quadratic equation. And once you know that you're dealing with a quadratic equation, then you can use different methods to solve it. One of the methods is factoring. So a quadratic equation is an equation of the second degree. The standard form of a quadratic equation is ax squared plus bx plus c equals 0. And this a and this b and this c are all going to be real numbers where a cannot be equal to 0. So it can be any real number except for a cannot be 0. So a very important property that we need to know in order to solve quadratic equations by factoring is the zero product property. And what that says is if you have an equation where you have two factors, x and y, and they're equal to 0, then that means either x has to be 0 or y has to be 0. That's the only way that the answer can be 0 is if one of the factors is 0. They could also possibly could both be equal to 0. That's a possibility as well. But we know at least one of them has to be. So we're going to use this property to solve quadratic equations. So here's another example. If p times q equals 0, then p equals 0 or q equals 0. Let's start with an example where we have a quadratic equation that's already been factored. So we have x minus 5 times x plus 2. Now, if I were to multiply this out by using the FOIL or box method, I would have an x squared because x times x is x squared, which means this is a quadratic equation. It's just already been factored. So I have this factor, x minus 5, and I have this factor, x plus 2. So I have this times this is equal to 0. So using the product property rule, the zero product property rule, I know that this factor, x minus 5, is equal to 0, or x plus 2 is equal to 0. And then I can solve for x. So I add 5 to both sides, x equals 5. Subtract 2 from both sides, x equals negative 2. So now I have solved this quadratic equation. X is either equal to 5 or x is equal to negative 2. So those are my solutions. So many quadratic equations actually have to be factored before you can apply the zero product property. Be sure to have a 0 on one side of the equation before factoring. It has to be a 0 if you want to use the zero product property. Let's look at this example. We have x squared plus 8x plus 12. This is a quadratic equation because the degree is 2, which means that we can use the method of factoring to solve the quadratic equation. So the first thing we have to do is factor x squared plus 8x plus 12. We have to make sure that it's set equal to 0, which it is, and we can either use the box method or reverse the FOIL method to get our factors. We end up with x plus 2 times x plus 6, and again it's still equal to 0. So now we apply the zero product property, which says that either x plus 2 equals 0 or x plus 6 equals 0. We'll solve for x, and then that will give us our solutions. We need to make sure that we check our solutions in the original equation. Here we have this example, 8x squared minus 16x equals 0. So we know this is a quadratic equation because we have an x squared. It's a second degree polynomial. Now this is a binomial, which means one way we can factor is just factoring out any common monomials. So these two terms share at least one x, and they also share a factor of 8. So I can factor out an 8x, which leaves me x minus 2. Now I can apply the zero product property, and that means that either 8x is equal to 0, because that's my first factor, or x minus 2 is equal to 0. Then I solve for x on both sides, and I end up with x equals 0 or x equals 2. So here are your steps for solving quadratic equations. Step 1, write the equation in standard form, so make sure that it's set equal to 0. Factor the polynomial side of the equation, and set each factor that contains a variable equal to 0 using the zero product property. Solve the resulting equations, and then check your solutions in the original equation. So let's look at this example. We have 2x squared plus 8x minus 42 equals 0. This is a quadratic equation because we have x squared. So we can use factoring to solve this equation. We want to make sure that it's written in standard form. It's set equal to 0, which it is. And even though this is a trinomial, I'm going to go ahead and factor out a common factor before I factor it using the FOIL method or the box method. I noticed that each of these terms can pull out a 2. So I'm going to factor out a 2 first, and that gives me a trinomial that's going to be a little bit easier to factor using the reverse box method or reverse FOIL method. So x squared plus 4x minus 21 factors to x plus 7, or x minus 3. And now I have my 3 factors. Now, when I set my 3 factors equal to 0, 2 does not equal 0. So I need to make sure that I put that as part of my answer. That I end up with 2 equals 0, but that does not make sense. So we need to make sure that we can state 2 does not equal 0. We also have x plus 7 equals 0 and x minus 3 equals 0. So we solve for x and we get our solutions negative 7 and 3. Here's our next example. We have 3x squared equals 147. So if this is a quadratic equation, because we have as x squared, and so if we want to solve this by factoring, we would have to set it equal to 0 first. So we'll subtract 147 from both sides. I'm going to go ahead and factor out a 3 because they both share a factor of 3, giving me x squared minus 49 on the inside. And then I recognize that this right here is difference of squares because x is a perfect square and 49 is a perfect square, which means that it will factor into x minus 7, x plus 7. And now I can apply the zero product property, which says that 3 is not equal to 0, x minus 7 is equal to 0, or x plus 7 is equal to 0. So I'll solve for x, and I'll get my 2 solutions. Okay, so quadratic equations will have at most 2 real number solutions. Now it's possible that they only have 1 real solution, but at most they'll have 2. The zero product property can also be applied to equations with higher degrees after they have been factored. So here's an example where it is not a quadratic, it's a trinomial, it's a degree 3, right? So it's not quadratic, but we can still use the zero product property. So we would get everything set equal to 0, and then we'll factor. So it looks like each of these terms, we can factor out an x, and it looks like they all have a 2 that we can factor out. So we're going to factor out 2x, leaving us 2x squared minus 7x minus 4. And then we'll go ahead and factor 2x squared minus 7x minus 4, either reversing the box method or reversing the FOIL method. We'll get 2x plus 1 and x minus 4. Now we can apply the zero product property, and we get 2x equals 0, or 2x plus 1 equals 0, or x minus 4 equals 0. We'll solve for x, and we get our 3 solutions, x equals 0, x equals negative 1/2, and x equals 4. Now, remember I had said that a quadratic equation will have at most 2 solutions, and if you think about it, we had x squared, so it was a degree 2, so at most it could have 2 solutions. This has a third degree polynomial, and as a third degree polynomial, you can have at most 3 solutions, and that will always work out that way. Whatever your degree is the most solutions you can have. Dividing both sides of an equation by a variable expression causes a solution to be lost, which means that you cannot use it anymore. Some word problems require you to write and solve a quadratic equation. So for example 7, we have a problem where we're trying to solve for the width. So we know that we have W, which is our width, and we know that the length is 5 more than the width. And then we know that the area is equal to length times width, and they told us that the area is 204. So this is what the problem tells us. They tell us that we have a width, and we have a length that's 5 more than the width, and that the area of it is 204. So we can plug in our variables, W for width, and W plus 5 for length, equals 204. From here, we can go ahead and distribute the W, so we get W squared and 5W equals 204. So I noticed that we have a quadratic because we have a degree 2. In order to solve a quadratic, I can factor. So I'll get it into general form by getting it set equal to 0, and then I'll factor using the reverse box method or reverse FOIL method, which gives me W plus 17 and W minus 12. Then I'll use the zero product property, and I end up with W plus 17 equals 0, or W minus 12 equals 0. I'll solve for W, and I get negative 16 or 12. Now, it's important to think about the problem. If I'm solving for width, which is a measurement, I can't have a negative measurement. So since I can't have a negative measurement, that means our width has to be 12. And if our width is 12, and that means the length needs to be 5 more, which means our length needs to be 17. So I can check my solution. Is 12 times 17 204? Yes, it is, which means that these solutions work.